Today, we are going to talk about random variables which are continuous. The two special examples we will work out are normal probability distribution and uniform probability distribution. So our learning objectives are identification of a continuous random variable, calculate probabilities for uniform probability distribution, and explain and understand normal probability distribution. A random variable is a variable that takes the quantitative values representing the results of probability experiment, and thus the values are determined by chance. We denote random variables using capital letters such as X, Y, or Z. Continuous random variables, however, assume infinitely many possible values with no gap between the values. For example, the height of randomly chosen student is a continuous random variable because it can take any value, and so there are uncountably infinitely many options. For a given continuous random variable x, we are not interested in whether x equals to a particular value. Remember when we were talking about discrete probability distribution, we were finding probability of x equal to the value of the random variable. For continuous random variable, those data are insignificant. In fact, the probability that a continuous random variable is exactly equal to a value is always going to be equal to 0. So we will be rather interested in probability that the random variable is greater than a particular value, less than a particular value, or is in between two particular values. One other key thing that we will remember for continuous random variable, that greater than or equal to will give you the same probability for the random variable. For example, probability of x greater than a is exactly equal to probability of x greater than or equal to a, or I can say probability of x less than a is exactly equal to probability of x less than equal to a, even if I want the value to be in between two variables. For example, a less than x less than b. It doesn't matter whether I throw in the equality with the signs of the inequalities. So I can say probability of a less equal to x. I can or I cannot. It doesn't matter again whether I put in the equality signs. They're all equal. So the gist of this information and how continuous random variable are going to look way different from the discrete random variable. At a point, if you say x equal to a point, for continuous random variable, the probability is always 0. The continuous probability distribution, a continuous probability distribution is a graph that indicates on the horizontal axis the range of values that the variable can take, and above which a curve will be drawn, which will be called the density curve, and the continuous probability distribution must meet the following requirements. The total area under the density curve must be equal to 1. The vertical height of the density curve can never be negative, so it is always over the x-axis. That is, density curve never goes below the horizontal axis. Probability for a continuous distribution, the probability that a continuous random variable x takes a value in an interval is equal to the area under the density curve above that interval. So we're going to understand all these information for two special continuous random variables. One of them is the uniform probability distribution. The uniform probability distribution is a continuous probability distribution that has constant probability from left endpoint to a right endpoint B. Its curve is a flat straight line, so that the shape of the uniform distribution is a rectangle. So I'm just going to give you one simple example of a uniform probability distribution. So this is my x-axis. So the probability distribution looks like a straight line parallel to the x-axis. If I want to know how much is the probability in between the numbers a and b, what I do, I say probability a less equal to x less equal to b is equal to the length of the line of the uniform probability distribution from a to b over the total length of the distribution. So for example, say my probability distribution is defined from this value, capital A, to this value, capital B, then the probability that I am between small a and small b is going to be length of the straight line, small a to small b, which is b minus a, over the total length of the uniform probability distribution, which is capital A to capital B, and that length is b minus a. And that's how we are going to understand the uniform probability distribution. If it is not making very clear sense, don't worry about it. I'm just going to skip page number 2 and go to page number 3 and start working on a continuous uniform probability distribution, and you will see things are not that difficult. So let's go to an example for uniform probability distribution. So this one says that assume that x is a uniform random variable with left endpoint at 0 and right endpoint at 100. So according to my picture previously, I'm saying the uniform probability distribution start at 0 and ends at 100. This is the total range of the distribution. So 0 to 100. That's the total distribution. And I am interested in finding the following probabilities. Probability of x is between 50 and 100. So what I'm wanting for the first example is what is the length of the straight line if instead of starting at 0, I start at 50. So I'm going to say that, well, the end point is still 100, so 100 minus 50 over the total range, which is 100 minus 0. So see, this one is 50 over 100, and hence the probability is 1/2. Now I want between 15 and 35. So I still have the same probability distribution, but now I want between 15 and 35. So it started at 0, ended at 100. But I want between 15 and say 35. So that is the length I'm interested in. So I will say 35 minus 15 on top. Bottom is still 100 minus 0. That's the entire range. So you get 20 over 100, which is 1 over 5. And that's how we're going to answer all the questions. Now, I think you have already observed one thing. The last problem did not have equality with the inequality signs. The work I have produced for the last one, I produced the exact same work for this one where I do have equality. So I want to reiterate the fact that equality in continuous random variable doesn't change any information. Probability that the uniform random variable is between 50 and 100. This time you have the equality. So what it is going to be? Well, I'm not going to change anything. It is just like the problem A, the first one. It will still say that this is 100 minus 50 over 100 minus 0. So that's 50 over 100, and that is equal to 1/2. Between 24 and 25. So this one is your random variable starting at 0, going to 100. That's the entire range. But I am interested in the region starting at 24 and ending at 25 immediately. So you are interested in this length. So you will say that this is 25 minus 24 all over 100 minus 0, which is 1 over 100. That would answer your question. Between 25 and 90. So between 25 and 90, it's always a very good habit to draw the picture in every single problem, even though it is pretty simple. The picture makes the continuous probability distribution understanding so much better. So I'm interested in 25 till 90. So that length, which is 90 minus 25 over 100 minus 0, and that number is going to be 65 all over 100. So if I divide both top and bottom by 5, I get 13 over 20 as the final probability. Between 25 and 25. So this thing, I'm going to work it out. Even though when I see between 25 and 25, since I'm using the same number, I can go ahead and directly say that the answer is going to be 0, even though I want to show you why it is going to be 0. The range is from 0 to 100, and I want to know the length of this straight line from 25 to 25. So see, the top is going to be 25 minus 25. Over the range is 100 minus 0. So the top is 0. It doesn't matter how much is the bottom. Since the bottom is non-zero, this ratio is going to be 0. So the probability is 0. So now and so on, if someone asks you to find the probability between the same number, between 25 and 25, between 76 and 76, for a continuous random variable, without showing any work, you can directly go ahead and say that the probability will be exactly equal to 0. This is a different example for a continuous random variable, still uniformly distributed. So suppose a random variable x is best described by uniform probability distribution with the range of 1 through 4. Find the values of a that makes the following probability statements true. So what I'm saying, first think about the range. It's between 1 and 4. So the range is this rectangle, 1 to 4. And I want some a such that, so your a is in between somewhere, say that it's here, such that probability of x being less than or equal to a. So I'm here, the probability of this portion, x being less than equal to a, is 0.82. So what formula I'm going to use for this one? So when I say probability of x less equal to a, in our problem, as you can imagine, you start at 1 and you end at a. So you get a minus 1 on top, whereas the range of the entire probability is 4 minus 1. So you get a minus 1 over 3, and I told you this is 0.82, and I asked you to solve for a. So this is a linear equation. You multiply 3 on both sides, you get a minus 1 equal to 0.82 times 3, which is 2.46. So you get a minus 1 equal to 2.46, implies a is equal to 2.46 plus 1, and that is 3.46. And your answer is done. And that's why I feel for every single continuous probability distribution, you should be able to draw the diagram which just clearly executes the problem for you. You basically don't have to do anything once you draw the diagram. Understanding the way we are going to execute the problem becomes so much easier. Let's think about the next one. Isn't that the exact same problem? It's just the 0.4 is different than 0.82. Remember, the strict inequality and the equality doesn't change anything. So I still have the same setup. I have 1 where the distribution started and 4 where the distribution ends. So that's the entire range. I want an intermediate point A, and I want my x to be less than and equal to a. So I'm talking about this region. And that probability should be 0.4. So I still start at 1, end at a. So on the top I get a minus 1. And on the bottom I get 4 minus 1, and that is 0.4. And that's why I said that it is exactly like the last one. So you get a minus 1 over 3 equal to 0.4. You multiply 3 on both sides. You get a minus 1 equal to 3 times 0.4, which is 1.2. Add 1 to both sides. You get a equal to 2.2. And that's your answer. So this time you found your a is 2.2, whereas last time it was 3.46. Let's try to do a couple more of this type. I'm not changing the distribution, I'm changing the orientation of the probability. So still the distribution is defined between 1 and 4, and it's uniform, so I get this rectangle region. I want to know an intermediate a such that whenever x is greater or equal to a, so I'm in this region now, the probability is 0.12. See, this time you're starting at a, you're ending at 4. So on top you get 4 minus a. The bottom is still the same, it's the entire range, 4 minus 1. So you get 4 minus a over 3 equal to 0.12. Multiply 3 on both sides, you get 4 minus a equal to 0.12 times 3. So you get 4 minus a equal to 0.36. And then you subtract 4 from both sides. So you get minus a is equal to negative 3.64 when I simplify the right hand side. I wanted a, so my a is going to be positive 3.64, and that would answer my question. So I found a is equal to 3.64. The next problem is precisely the same problem. Remember, doesn't matter whether I have equality with a or not. So I still have the same region 1 to 4, and I have my intermediate a, and I'm saying as long as x is greater than this a, the probability is going to be 0.79. So you start at a, end at 4, top is still 4 minus a, bottom is always the entire range, and that should be 0.79. So you get 4 minus a over 3 equal to 0.79. Let's multiply 3 on both sides. I get 4 minus a is equal to 3 times 0.79. Let's multiply these two numbers. 3 times 9 is 27, 2 carries on. 3 times 7 is 21, so I get 23. So I will say 2.37. Then I'm going to, like the last one, subtract 4 from both sides. And I will get negative a is equal to negative 1.63. When you subtract 4 from 2.37, you get negative 1.63. So a, the required value, is positive 1.63. That answers my question. The last one is between two numbers 1.1 and a. So in this situation, I will draw the range one more time. And this is 1 and 4. And I am the rectangle in between. I want between 1.1 and some a, and I want to say that this region, the probability is 0.12. So see, you started at 1.1 and ended at a, so the top is a minus 1.1, the bottom is still 4 minus 1, that should be 0.12. So as usual, you get a minus 1.1 over 3 equal to 0.12. So multiply 3 on both sides. You get a minus 1.1 equal to 3 times 0.12, which is 0.36. So solving for a, I will add 1.1 on both sides. So 1.1 plus 0.36 will give me 1.46 as the final answer to the required value for a. And that would answer my question. So this is all we can think of uniform probability distribution. The other probability distribution, whereas, is going to be the most important probability distribution that we're going to ever talk in a statistics class. And that's called a normal probability distribution. The mathematical intricacy of a normal probability distribution is unparalleled. Again, because we have limited tools to deal with a probability distribution in our class, we will be mostly concerned about the way we can interpret and understand a normal probability distribution and hence be able to use it. Let's go back to page 2. A normal probability distribution has a picture like this. The empirical rule says that almost 68% of the data for a normal distribution falls between mu minus sigma to mu plus sigma, where mu is the mean of the normal distribution and sigma is the standard deviation of the normal distribution. Almost 95% of the data falls between mu minus 2 sigma to mu plus 2 sigma, and 99.7% of the entire distribution falls between mu minus 3 sigma and mu plus 3 sigma. This rule is called empirical rule. When we can or when we are asked, we will use empirical rule in order to talk about probability under a normal distribution. Some properties, some fascinating properties of normal distribution that we will be using for the rest of the semester. It is symmetric about the mean. So if you think of the mean as the center of the distribution, the graph is pretty symmetric on the two sides. Fascinatingly, the mean is equal to the median is equal to the mode for a normal distribution. All three central tendencies are the same. The highest point occurs at x equal to mu, so it is the mode as well. The total area under this curve is 1. And this is the most interesting fact about a normal distribution. As you can imagine, this curve doesn't end anywhere. It goes all the way to negative infinity. And it goes all the way to positive infinity. Still, the total area under the curve is not at all any greater than 1. It is in fact exactly equal to 1. That's why it is a probability distribution. So an infinite area which is finite in quantity. Symmetry is also going to imply that the area on the two sides of the mean are both 0.5. So on the left of the mean, the area is 0.5, half of 1. And on the right of the mean, the area is still 0.5. So precisely if we have access to the first core property and we have access to the standard normal table or Z table, which I have shared with you in your shared class file, and we will use it today in class, we can answer pretty much any and every question. So now and so on, I want you to have this table always accessible in your hand, the normal distribution table. I will show you it in a second. Remember the empirical rule, remember the symmetry property of normal distribution, because I will use it every single class now and so on. So let's go back to page 4 and keep answering questions. Barth weights are normally distributed with a mean weight of 3,285 grams and a standard deviation of 500 grams. And I'm going to answer a bunch of questions with this information. First and foremost, every single normal distribution problem will start with a picture and proper shading of the area. What do I mean by that? See, the first question is asking you, what is the probability of Barth weight equal to 3285 grams? So I'm asking you, probability X is exactly equal to 3285 grams. How do I know that information? Well, I don't have to do anything. Remember, this is a continuous random variable. Exact equality will always be equal to 0. And I have answered it. The second one, whereas it is asking you, what is the probability of a Barth weight more than 3285 grams? So I start drawing the normal distribution. I know that it is normal distribution. I say the mean is given to be 3285. And I want more than 3285. So I want to shade what is more than 3285. And then I write it in notation. Probability X is more than 3285. This is just the area to the right of the mean. Remember, it is half of the entire area because of the symmetry. So it is 0.5. And you have answered the first question. What is the probability of a Barth weight at least 3285 grams? So again, normal distribution, bell curve, mandatory. You draw it all the time. 3285. At least 3285 means either I am equal to 3285 grams or I am greater than 3285 grams. So how do I write it in notation? I say probability X is greater than or equal to 3285 grams. As you can imagine, that doesn't change anything. Greater than or greater than and equal to for continuous random variable does not change any information. So I have both probabilities at 0.5. So we're going to go ahead and start answering our next question. So let's go ahead and start answering questions from the fourth one. Is the area to the right of the X value 4285 grams greater than or less than 0.5? How do you know this? So what we will do for this one, as we have done it for the other problems, we will first draw the required area and shade it. So normal distribution, bell curve, mean is 3285, and you're thinking about 4285. 4285 is clearly on the right of 3285, and it says the right of this data. So this is the area I'm talking about, and the question is it less than or greater than 0.5? Well, it is clearly less than 0.5, so I will say the area is less than 0.5. How come? Because it is the right of 3285 is 0, and this is way farther right, as the right of the data (3285) is 0.5. So anything further right will have less area because you're shifting it towards the terminal of the total area. So that answers my question. How about the next one? The next one is the area to the left of 4285 is less than or greater than 0.5. So I will do it. 3285 is my mean given in that problem. 4285 is on the right of 3285, and now I'm shading the left of this. So clearly it is greater than 0.5. So I will say it is greater than 0.5 as left of 3285. See, 3285 is the mean, so left of 3285 is already 0.5. So anything further right will be more. So anything further right of 0. I should say 3285. Anything further right of 3285 is more than 0.5. It's pretty easy to understand at this point. What is the probability of a Barth weight between 2785 and 3785 grams? Well, normal distribution, and I have the mean at 3285, and this is 3785 on the right, whereas 2785, as you can imagine, will be on the left of the mean. Now think about one thing. How much you get when you subtract 500 from 3285? So 3285 minus 500 is exactly equal to 2785. How about you add 500 to 3285? What do you get? You get exactly 3785. And I'm interested in learning how much is the area in between these two marks. Remember why I use the number 500? If you go back to the original problem, it said that 500 is the standard deviation of this distribution. So mean is 3250, sigma is 500. So how can I write this thing? Remember, this is mu. This marking here is actually mu minus sigma. And this marking here is mu plus sigma. And remember, the empirical rule has told me that between mu minus sigma and mu plus sigma, I have 68% of the data. But I am interested in the probability. So I will go ahead and write it in notation first. I will say that probability that I am between 2785 and 3785 is equal to 68% in terms of probability is 0.68. And that answers my question. Now I have used strict inequality. If you want, you can go ahead and put the less than or equal to, will not change any further information. What is the probability of a Barth weight between 1785 and 4785? So now I want to do 1785 and 4785. Draw it, shade it, and the answer should be pretty clear from there. Mean is 3285, 1785, and the other information is 4785. So 1785, you can think of that as 3285 minus 3 times 500. If you do so, you get 1785. I can verify that for you because I can understand the numbers faster. I have the answer readily. We can always verify this information by going to our calculator. And I will need 1 minute to find the calculator. Let's do that. So as I said, I had 3285 minus 3 times 500, and that's 1785. Similarly, if I do 3285 plus 3 times 500, I will get 4785, which is other information in this problem. So now I'm saying that you can write 4785 as 3285 plus 3 times 500. Why does that help? because I wanted to know the information, the probability between these two marks. Think about the left hand point, it is mu minus 3 sigma. And this is mu plus 3 sigma. So you want the probability between 1785, and as usual, I can use strict inequality or less than or equal to, does not matter. And this one I want 4785. So that is the area between mu minus 3 sigma and mu plus 3 sigma. Go back to empirical rule, and that area is almost all of it, 99.7%. Change it to probability and you will get 0.997. So answers to your question. The next question is asking you, what is the probability of a Barth weight between 785 and 5,785 grams? So let's try to understand that. Mean is still 3285, and I want to understand between 785 and 5,785. Now remember, you had your 99.7% in fact between 1785 and 4785. Last problem has shown you that this region is already 99.7%, or 0.997 is the probability. I want to find the probability for even further bigger region. So what it is going to be? Total area could be 1. The maximum probability could be 1. I already have 0.997. So it will be in between 0.997 and 1. It is almost going to be equal to 1. So I can go ahead and without any risk, I can say that between 785 and 5,785, the probability is almost equal to 1. So this is the approximation sign. It is almost equal to 1. It's almost between 99.7% and 100%. So it's almost 100%. Answers my question. Let's change all these argument to a real life problem. Math scores. The National Center for Education Statistics reports that in 2005, the mean score on the standardized mathematics test for 8th graders increased by 7 points from 2000. The mean score, mu, is 273, standard deviation is 7. First question is, shade the region that represents a score between 266 and 273. So let's see what we have. Mean is given to be 273. And I want the region between 266 and 273. That's my first question. I answered it. What is the probability that the students score between 266 and 273? So now I want the probability. So probability between 266 less than x less than 273. Again, just reminding you, can put the equality there. It will not change anything. So what you would like to do, you would like to write 266 as 273 minus 1 times sigma, which is 7. Remember, 1 times sigma, if you subtract 7 from 273, you get 266. What does that mean? It means it's mu minus sigma to mu. How do I know that area? Well, if I go to empirical rule, it tells me between mu minus sigma and mu plus sigma, I have 68%. But now I am talking about only one side of it. Remember, the graph is symmetric, so it must be half of 68%. And that's all I needed to know. Half of 68% is 34%, which is going to help you answer this question. So we'll go ahead and say that this is going to be 0.34. I cannot write percentages because I'm writing probability. So it's half of 68%, which is 34%. And I say that it's 0.34. Answers my question. All right. The one other key information that we're going to learn in our class today is using the standard normal table, but I believe there are more problems that we can just solve using the empirical rule, and we'll go ahead and try to finish them all first. Engineers' salaries. According to the US Census Bureau, students in their first year after graduating with bachelor's degrees in engineering earned an average salary of $3,189 per month. So this is the mean. So I will say mean is 3189. Assume that the distribution is normal, so I can use the empirical rule, with the mean of 3189 and the standard deviation of 600. So sigma is 600. What proportion of salaries lies between 3789 and 4389? See the word proportion? So now I'm not talking about probability, I'm talking about percentages. You can write your answer in terms of percentages. Draw the diagram. The mean is 3189. That's the central location. You want the probability, the proportion between 3789 and 4389. You want to write both of them in terms of 3189 and the standard deviation. See whether we can do it or not. See, 3789 is 3189 plus 600, as simple as that. So this is just mu plus sigma, and you want the information in between. 4389 is 3189 plus 2 times 600. So this is mu plus 2 sigma, and I want this much. So how do I answer this question? Again, you can go back and think about the empirical rule. Why I said that? Think about, in the empirical rule, how much percentages you have in between the 2 standard deviation marks. Between the 2 standard deviation marks, I have 95% of all the data. So that is from here till here. All of that is 95. So on the right hand side only, if I discard this portion, you have half of 95%. So it is 95 over 2. Then you think about how much percentages you have between the 1 standard deviation mark. So if I talk about only this much, that is 68 from empirical rule. Think about how much you have only on the right hand side of this. So the green portion on the right hand side is half of 68, so that's minus 68 over 2. If I subtract this green portion from the black shaded portion, then what is left? The black shaded portion, subtract this green shaded portion. Don't I have exactly what I need between mu plus sigma and mu plus 2 sigma? And you have your answer right there. So how did I solve this problem? By empirical rule and a little bit of manipulation. So I wanted the area between mu plus sigma and mu plus 2 sigma. What I do, I tell myself, if I have mu minus 2 sigma to mu plus 2 sigma, all of that region between mu minus 2 sigma to mu plus 2 sigma, that is 95%. So this entire thing is 95%. So half of it is 95% over 2. So in this situation, I do not have this portion, just the half of it. I'm interested in this. Then I said, what is the area between mu minus sigma to mu plus sigma? So if this is mu plus sigma, this is mu minus sigma, what is the area in between? Well, the total area is 68%, and I want just the half of it because I want only on the right hand side. So I do not want anything on this portion. So that is 68 over 2%. Then I said that I am only interested in from the red barrier mu plus sigma to the green barrier mu plus 2 sigma. So I don't even want this portion here. That will be what? Well, that will be whatever was in green minus whatever you got in red. So I will say that this answer, probability that I am between 3189 less than 4389 is equal to 95 over 2 minus 68 over 2. Because it is talking about percentile, I can use percentages. So see, the first one is 47.5 minus 34. So you get 13.5 percentages, and that answers your question for the first one. The second part of the question is asking what proportion of salary is greater than 2589. So now I want to talk about greater than 2589. Well, let's see. 3189 is the mean, and if you think about 2589, it's less than the mean, and I want all of this. Now this one is a little easier because 2589, you can think of that as 3189 minus 600. So this is mu minus sigma. Remember, this is the mu. Between mu minus sigma and mu, you have half of 68. So this overly shaded region is half of 68% from the empirical rule. So I have 68 over 2. And remember, to the right of the mean, you have 50%. So that's what I am looking for. So I will say probability, and how do I write it? My x this time should be greater than, because the question asked that what will be the proportion that it is greater than 2589. So x should be greater than 2589, and that should be 68 over 2 plus 50, exactly what we found out, percentile. So 34 plus 50 percentile, which is 84 percentile, answers my question. Let's do the next one. It is talking about tobacco-related deaths. The World Health Organization states that tobacco is the second leading cause of death in the world. Every year, an average of 5 million people die of tobacco-related causes. Assume the distribution is normal with a mean of 5 million. So mu is 5. And the standard deviation is 1 million. So sigma is 1. What is the probability that between 4 and 7 million deaths will occur? So normal distribution, so I will draw the bell curve with the mean equal to 5. I want it between 4 and 7. So what are 4 and 7? 4 is 5 minus 1. So if you call 5 as your mu, this is mu minus sigma. 7 is 5 plus 2 times 1. So it's mu plus 2 sigma. So I want the area between mu minus sigma and mu, and add the area between mu and mu plus 2 sigma. Remember, between mu minus sigma and mu is half of 68%, and between mu and mu plus 2 sigma is half of 95%. But because I'm talking about probability, I will find this number, which is going to be 34 plus 47.5, and change it to decimal expression for probability. So I add them, I get 0.5, 7 plus 4 is 11, 1 carries out, and 4 plus 4 is 8. So 81.5%, which is 0.815 in probability. And how I answer my question? The tobacco-related death between 4 millions, that's what I wanted, and 7 millions is 0.815. Answers my question. On all these answers, I'm doing just by using the empirical rule. The second part of the question is asking me to find the probability more than 6 million deaths. So I will say, draw the diagram. Mean is 5 million. So you identify 6 million, and you want more than this. Remember, this is mu. 6 is equal to 5 plus 1. So it is mu plus sigma. And you want this much. So how do I understand that? I will do it in a little different way. I remember that the right of the mean, so all of the right of mu is 50%, but between mu and mu plus sigma is half of 95%. What I want all of the right of mean minus between mu and mu plus sigma. So I will say I wanted to know the probability that I am greater than 6. Remember, it is greater than 6 million deaths. That will be 50%. So 0.5 in probability. 95 over 2, we know that that is going to be 47.5. So in probability, that is 0.475. And that's what we are wondering how much is going to be. So when you do the subtraction, you get 0.025. And that is the required probability of the number of deaths over 6 million for the tobacco-related deaths. Answered my question. Starting the next page of the handout, we will talk about basic rules and ideas of using the standard normal table in order to talk about probabilities. So what is a standard normal table? A standard normal table is a bunch of data value given for a special normal distribution. If the normal distribution has a mean of 0, so it is still a normal distribution, but this is special because it has a mean of 0 and a standard deviation of 1, then we call it a standard normal distribution. The table that I'm going to show you now has probability values given for z-scores or any number on this line. If your numbers are appearing on this line, the table is going to give you the probability to the left of that number. So for example, if I can find this number on the table, then it is going to show me the probability to the left of this number. So the table always gives you values for probability of the random variable being less than or equal to the given number. So say the given number is A, that we call z-score. And for a standard normal distribution, the random variable we use is z. So the table always gives you values of this form. And we're going to be able to use them, and we will be able to find areas on left, right, or in between. Probabilities to the left, right, or in between. So I will skip this description and show you how to execute problems. So let's get the table, and it's pretty easy to find out. I will talk 2 more minutes about the table. If I go to shared class file and click on tables, the standard normal or z table, this is going to be one of the most important table for our class now and so on. It has 2 pages. The first one are all negative z-scores and the second page are all positive z-scores. How do you read z-scores? So for example, if I look at the row number 3, it starts with negative 3.2. What are the columns? The columns refer to the second decimal place. So if I look at this number, this is the probability to the left of the z-score, negative 3.20. If I look at this number, this is the probability to the left of the z-score, negative 3.21. And that's how we will find all the probability values. So let's actually start answering questions, and I think it will be easier in that way to recognize values from the table. Find the area under the standard normal curve. Very important. If you are not standard normal, you cannot use this table. Find the area under the standard normal curve. So since I said standard normal, I will draw the picture. Mean is always 0. That lies to the left of the following, the left of z equal to 1. So I want the left. Remember, left is directly computed from the table. This is exactly what will be given to me. So what I'm going to write, I'm going to say this is probability of z left, so less equal to 1.00. That's what I'm looking for. Probability of z less equal to 1.00. Since the z-score is positive, I will go to my standard normal table and I will tell myself it is on the second page, the positive page. See, 1.00 is this row and this column, and the value is 0.8413. Answers your question. So it will directly say that this is equal to 0.8413. Pretty simple. The next one is to the left of negative 2.7. Mean is 0. Identify negative 2.7, that should be on the left of 0. And you want the left of this. So this is on the left side of the z-score. So you want probability of z less equal to negative 2.70. So find the row negative 2.7 and find the column 0, 0. It is the left side of the table or the negative side of the table. Row is negative 2.7, column is 0, 0. So that's 0.0035. Answers my question. Negative 1.2 and the left of that. I draw my standard normal, 0, and negative 1.2 will be left of 0, and I want the left hand side of that. How do I write it? It's probability z less equal to negative 1.20. So I go to row negative 1.2 and I use the column 0, 0 on the negative side of the table. So negative 1.2 is the row, 0, 0 is the column. I get 0.1151 as my answer. So these are all values that can be directly computed from the table. As you can imagine, the table always gives the area to the left. So if I want to find the area to the right, I have to manipulate. So we'll do those exercises now. So the first one is find the area under the standard normal curve that lies in between. So again, I will just start the problem by drawing always. Standard normal, so 0, 1.28 is on the right of 0, 1.96 is even further right. Then write the notation. What do you want? You want probability of 1.28 less than z less than equal to 1.96. Remember, table gives you to the left. So what do? You first find all the area to the left of the higher z-score. So I mean, find this one. You will get it in the table. So write it. This is probability of z is less equal to 1.96. Then you do what? Then you subtract all the areas that is left to the lower z-score. So if you subtract the green portion from the red portion, you actually get your answer. So what you are subtracting? You are subtracting z being less equal to 1.28. So the general process, if I'm finding the area between two z-score, I find the area to the left directly from the table of the higher z-score, subtract the area to the left directly from the table to the left of the lower z-score, and I get my required. See, if you subtract the green region from the red, you get your desired region which you wanted to compute in black. So I will rewrite that one more time. I will say it's the probability of z being less equal to 1.96, the higher value, minus probability of z being less equal to 1.28. And remember, both of them you can find from the table directly. The first one is row 1.9, column 0.06. Row 1.9, positive, column 0.06. So I'm here. The value is 0.975. So let's write that down. It's 0.975, and I'm subtracting row 1.2, column 0.08. Row 1.2, column 0.08. So that's 0.8997 minus 0.8997, and I do the subtraction. 15 minus 7 is 8. 16 minus 9 is 7. 8 minus 8 is 0, so you get 0.078. I guess I should get... I actually did this calculation wrong. I'm so sorry. You should get 10 minus 7, 3, because this is a 0 here. And then you get 14 minus 9 equal to 5. And you will get 16 minus 9 equal to 7. 8 minus 8 equal to 0. So it is 0.0753. I can do the calculation in a calculator real quick, but that's what I'm going to get. Similar problem, I want the area between 2 and 3, or the probability. So the probability and the area, they're the same thing, between 2 and 3. So you will go ahead and first write it. You will say you want probability 2 less equal to z less equal to 3. So that is probability z less equal to 3. I can say 3.00 if it helps. Minus probability z less equal to the lower value 2.00. So I'm going to look for the row 3 and the row 2, column 0.00 for both of them. Let's do 3. It's 0.9987 and 2 is 0.9772. So I get 0.9987 minus 0.9772. And then I do the subtraction. 7 minus 2 is 5. 8 minus 7 is 1. 9 minus 7 is 2. 9 minus 9 is 0. So it's 0.0215. When you do the subtraction, you get 0.0215. Answers your question. Between negative 1.96 and negative 1.28. So this time both of your z-scores are on the negative side. Mean is 0. You get negative 1.28 closer to 0. Negative 1.96 is farther than negative 1.28 on the left. And I'm on this. But the process is pretty similar. I will say negative 1.96 less than or equal to z less than or equal to negative 1.28. So write probability z is less equal to the higher value between these two, negative 1.28, minus probability of z less equal to negative 1.96, the lower value. So both of these values will be found on the negative side of the table. So we'll go to the negative side of the table. First one is negative 1.96. So I go to the row negative 1.9 and the column 6, so 0.6. So 0, 1, 2, 3, 4, 5, 6. That's 0.0250. And then I do it for negative 1.28. This time the row is negative 1.2 and the column is 0.8. Negative 1.2, column is 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's 0.1003. 0.1003. And then I do the subtraction. So I get 3 minus 0 is 3, 10 minus 5 is 5, 9 minus 2 is 7, and 0 minus 0 is 0. So 0.0753 is your required probability that the z-score is between negative 1.96 and negative 1.28. How about I'm trying to find the area to the right? When you're trying to find the area to the right, you will use the z-score, but find the area to the left from the table and subtract from the total area, which is 1, as simple as that. So I want the area to the right of 2.12. Mean is 0, 2.12 is somewhere here on the right. I want this thing. So I write it first. Probability of z, this time see you are greater than 2.12, which is 1 minus probability z less equal to 2.12. So find the area to the left, which is directly coming from the table, and subtract from 1, and it would answer your question. Okay, so let's try to do that. We'll go to my table, and I want 2.12. 2.1 is the row, 0, 1, 2 is the column, so that's 0.9830. So I go ahead and say that this is 1 minus 0.9830. I do the subtraction, I get 0, and then I get 9 minus 3 is, actually that should be 7. 10 minus 3 will be 7. 9 minus 7 will be 2, and 9 minus 9 will be 0. So it's 0.0270. Let's see. I guess that should be 0.0170. Yeah, we need to check this calculation in calculator always. I'm trying to kind of rush through this topic. So 0, 3 plus 7 is 10, 8 plus 1 is 9 plus 1 is 10, and then I'm like, yes, so that makes sense. It's 0.0170. Now I want the area to the right of 3.01. So mean is 0, 3.01, the same process, you go to the row 3.0 and the column 0, 1. So first I write, I want the area to the right of 3.01, and I kept saying area and probability interchangeably because they mean the same thing. This is 1 minus probability. Z is less equal to 3.01. So let's find that from the table. It's the same side of the table, the positive side of the table. 3.01 is going to be 0th column and the first column, so 9987. So it's 1 minus 0.9987. As you can imagine, your answer is going to be 0.0013. Similar problems. Find the indicated probability for the standard normal Z. Draw a graph. Find the area using Z table. So still doing the same thing. Z greater than 1.29. So I'm talking about the right hand side. And I will say mean is 0. 1.29, and I want this. Well, how do I interpret that? I say that this is equal to 1 minus probability of Z less equal to 1.29, which comes from the table and would answer my question. Let's see, 1.29 gives you what? 1.2 is the row 1.2, and the column is the last column, which is 0.9015. So 1 minus 0.9015, and then I do the subtraction and I get 0.0, and I believe this is going to be 885. Is that right? 5 plus 5 is 10, 8 plus 1 is 9 plus 1 is 10, and then I want, I guess this is going to be 95. 95. Let me check my work one more time. 5 plus 5 is 0, 1 plus 8 is 9 plus 1 is 10, and 1 plus 9 is 10. Yes, so 0.0985 answers your question. We have more. This time you want Z is less than negative 2.17. So this one can directly be computed from the table. Negative 2.17 is on the left of the mean, and I want even further left. I want this thing, which is directly from the table. Go to the negative side of the table and go to row number negative 2.1 and column number 0.7. Negative 2.1 and column is 0, 1, 2, 3, 4, 5, 6, and 7. So that's 0.0150. Directly your answer. Between negative 1.96 and 1.96. So this one is actually pretty nice because first and foremost, I will get negative 1.96 on the left and 1.96 on the right, and I want this area. What I can do, because I'm trying to find the area between two numbers, I can write it as probability of Z less than the higher number, that is from the table directly, minus probability of Z less than the lower number, which is also directly coming from the table. I can do that. We talked about it. What else I can do? I can just find the area to the left of negative 1.96. Find this red region. That's directly coming from the table. Remember, the graph is symmetric. So this area and the area to the right of 1.96 are the same. So what I can say, the black area is equal to the total area minus 2 times the probability of the area when Z is less than negative 1.96. So find it once, multiply it by 2, and subtract from 1. Whichever way you can work it out. The symmetry on normal distribution is so nice. It helps you compute problems, work out problems in so many different ways. So I'm going to do it in both ways. Let's first do the higher score minus the lower score. 1.96. So 1.96 is on the positive side. 1.9 is the row. Column is 6. So 0, 1, 2, 3, 4, 5, 6. It's 0.9750. So I say is equal to 0.9750. Left of negative 1.96 will be on the other side of the table. Negative 1.9 is the row. Column is 0, 1, 2, 3, 4, 5, 6. So that's 0.0250. And when I do the subtraction, I get 0.9500. That's my required answer. What else I said? I said find the area to the left of negative 1.96. We found it. That's 0.0250. To the left is 0.0250. This one is 0.0250. So this one being symmetric is also 0.0250. If I add them, subtract from 1, I get the inside. So 0.0250, two of them, one on left and one on right, and subtract from 1. So 1 minus, multiply 2, you get 0.0500, which is equal to 0.9500. Answers your question, whichever way you like it. Okay, find the z value with the following areas under the standard normal curve to its left. So now our questions are a little different. I want to associate these following areas to the left of a z-score. So what do I mean by that? Think about the mean, it is 0, and I know the left of the mean is 5. I want the area of 0.3336, so that should be somewhere here. I want this z-score so that the left of the z-score, this area this time, is 0.3336. So instead of looking for the z-score, you are looking for the area on the table now. So I still go to the table. I look for 0.3336. If you look at the picture, your z-score should be on the left-hand side. So you are looking for the negative side of the table. So look for the number in this cloud of numbers, 0.3336. So let's try to find it out. And let's see, 0.3336. I'm having a little hard time finding it. So there, 0.3336. Now see, this is in the row negative 0.4 and the column is 0, 1, 2, 3. So the z-score is negative 0.43. I wanted the z-score. I say it's negative 0.43. 0.3264. This is the area that I want on the left. So mean is 0. It's still less than 0.5, so it should be somewhere here. That's the z-score I want. And this area that I have shaded on the left of this z-score should be 0.3264. And you are trying to find this on the table. So let's see that. It's the same side of the table, the negative side of the table. And you are looking for 0.3264. And let's see whether we can find it. 0.3264 is here. The same row, negative 0.4. 0, 1, 2, 3, 4, 5 is the column. So it's negative 0.45. So z is equal to negative 0.45. Now I want the area to be 0.99 on the left hand side of the z-score. Mean is 0. This much is 0.5. I want more than that, so I should be here. And I'm saying this area to the left of this required z-score should be 0.99. So I'm looking for the number 0.99 on the table. So that should clearly, from the location of z, it's on the positive side of the table. And I'm looking for 0.99. So let's try to see 0.99. See, I don't have 0.99. I have 0.9898 and 0.9901. So 0.99 is in between. So what I do in this situation, I find the z-score for this one and I find the z-score for this one, for both of them. This one is row 2.3, column is 0, 1, 2, and this one is row 2.3, column is 0, 1, 2, 3. So what do I mean by that? You wanted 0.9, you did not get it on the table, and that might happen. You got two different z-scores. You got 0.9901 on the right, and you got the left z-score 0.999898. So I got this one and I got this one. So 0.9898. I need both of them. If I don't find the value, I need the value immediate to the left and I need the value immediate to the right. The z-score for the first one is 2 point, if you remember the row and the column for these data, the row was 2.3 and the column was 2 and 3. So for the first data, the column is 3. So 2, so negative 2. Let me check it one more time. So row is 2.3 and column is 0, 1, 2. Yes, 2.32. And the other data is going to be 2.33. So my required z-score is in between. How do I find in between? I take the average of these two z-score. So I say 2.32 plus 2.33 over 2, which is equal to 2.325. And that answers your question for the required z-score. The required z-score is 2.325. Find the z-value with following areas under the standard normal curve to the right. So now I want 0.8078 to the right. Okay, this is 0. To the right of the mean is 0.5. If you want more, you have to go even further left. So you are here. You want this, so that the right is 0.8078. But remember, your z table doesn't give you anything on the right. So can I talk about the left? Well, I can. How much is the left? The left is 1, the total, minus 0.8078. So I do the subtraction. I get 0.1922. And I look for this area from the table. Whatever I get is my required z. So clearly the location of z is on the left hand side. So I look for the negative side of the table. And I look for 0.1922. So let's try to find that. 0.1922 is here. Its column is 7 and the row is negative 0.8. So it's negative 0.87. So I go ahead and say that. The required z is negative 0.87. Answers to your question. We'll do similar problems a couple more times. This is on the right and you want 0.9788. Again, remember, the right of the mean is already 0.5. So if you want more, then you go farther left. So it is here, that's what you want. And you want this to be 0.9788. But can't find anything on the right from the z table. So let's go to the left and find this much, which is 1 minus 0.9788. And that number is going to be 0.0212. So I'm looking for 0.0212, which is clearly on the left side of the table. Let's find it out. 0.0212. It's here. Row is negative 2 and column is 0123. So it's negative 2.03. So the z I wanted is negative 2.03. Answers my question. Now I have one more. The location is pretty similar, as you can imagine. The area to the right is more than 0.5, so I want the z-score to the left of the mean, and the right of this z-score is 0.9998. So the left is what I will be looking for, and that will be 1 minus 0.9998. And as I can imagine, this is 0.0002. So look for this value on the left side of the table, 0.0002. Let's see, 0.0002 is there. It's row negative 3.4 and column is 0.09. So I get negative 3.49. So I go ahead and say that my required z is negative 3.49. Now I want the values of z that mark the boundaries of the indicated areas, the middle 80%. So now you want to talk about the middle 80%. So what does that mean? Remember, this is the mean 0. You want a value here and a value here so that the central area is going to be 80%. 80% in probability is 0.8. So how much is the area on the left of this marker? If this is 0.8 in the center, then this area plus this area should be the rest. That should be 0.2. But I want only the area to the left, so that will be half of the 0.2. So this one is 0.1. So look for the z-score on the negative side of the table that stands for the area 0.1. And remember, you might not be able to find it. So let's try to find 0.1, and as we are seeing, at least I don't see 0.1. I am seeing two close values, 0.0102 and 0.0099. So we have to go with them. 0.01 is not there. Oh, actually, I'm sorry. We wanted 0.1. I was looking for 0.01. So 0.1. Still, we are in no luck because 0.1 is not there. You have 0.1003 and 0.0985. So I need both of them. I need 0.1003. 0.1 I wanted, didn't get it. I got 0.1003 and I got 0.0985. Those are the two values I got, and I want to know their z-scores. See, both values are on the row, and that's negative 1.2 is the row, and the columns are 8 and 9. So I will say this one is negative 1.28, this one is negative 1.29, and I want the z to be the average of these things. So that will be negative 1.28 plus negative 1.29 over 2, which is equal to negative. If I add them and divide by 2, I get negative 1.285. This is negative 1.285, so it must be this one. And then use a symmetry, so this one must be 1.285. The question asked you, find the values of z that mark the boundaries of the indicated areas. You wanted two of them. So they are negative 1.285 and 1.285. Now I want the middle 95%. So 95%, again use the symmetry. I want two z-scores so that the central area is 95%, which is 0.95. So the same thing. How much is the rest? The rest is 1, the total, minus 0.95. So that will be 0.05. But I want only the left of this, that will be on the table. So I will take half of 0.05. And half of 0.05 is going to be 0.025. So you are looking for 0.025 from the table. Clearly it is going to be on the left side or the negative side of the table. Let's find out 0.025. In fact, I probably am not finding it. I want 0.025. No, I actually found it. It's here, 0.025. So it's row negative 1.9 and the column is the sixth one. So it's negative 1.96. So the number on the left is negative 1.96. That's the number on the left. Use the symmetry. So this number on the right will be 1.96. And you were done. So you wanted to know the two boundaries there, negative 1.96 and 1.96, that will have the central 95% of the data. Find the following areas without using z-table or technology. The area to the left of z is equal to negative 1.5 is given. So let's draw that. I'm not going to use z-table, just the symmetry. This is 0. And I said left of negative 1.5. So this area is given to you as 0.0668. Let's try to use that to answer our questions. First one, find the area to the right of. So I want the area to the right of, so I will say probability of z greater than negative 1.5, the right of negative 1.5. Well, clearly, if you know the left, you subtract it from the 1. So that will be 1 minus 0.0668, which when I subtract, I get 0.9332. Answers my question. The second one, probability, so it's asking you find the area to the right of z equal to 1.5. So I want probability z greater than 1.5. Let's draw this picture. (1.5) because the mean is 0, so 1.5 is on the right, and I want even further right. I want this area. Think about the symmetry. You already know from the given information, negative 1.5 has the area to the left, and that is 0.0668. The graph is symmetric, so whatever this is on the left of negative 1.5 will be exactly equal to whatever the right is of 1.5. So I don't even have to do any work. I will say this is 0.0668. The third one is between negative 1.5 and 1.5. So probability negative 1.5 less than z less than 1.5. Draw the picture. Mean is at 0. Negative 1.5 and 1.5. I want in between. But you know that the area to the left is given to be 0.0668. And we just found that the area to the right is also by the symmetry 0.0668. But I want the rest of the area. I want the in-between area. So that will be probability of the z being between negative 1.5 and 1.5. So that's 1 minus, subtract the area to the left and subtract the area to the right. And I get it done. So because I'm subtracting the same thing twice, I can multiply that by 2. So 2 times 8 is 16, or just you can use your calculator and subtract it twice. I will prefer multiplying. 2 times 8 is 16, 2 times 6 is 12, plus 1 is 13, and the same thing, so I get 0.1336. So this is 0.8664. That's the required area between the z-scores of negative 1.5 and 1.5. And this is our basic training on the continuous probability distribution using normal distribution. In our next lesson, we're going to talk about real-life application problem and use all these concepts we learned today and solve problems. Things are getting more and more interesting. So start working on the assigned problems. Let me know if you have any question. I will get back to you as soon as I can.